Welcome to CEI. This is Dr. Sekhar. Good morning, everybody. Today I'll continue my teaching. That is preparation of hydrogen. I have completed, and the next class I have already completed the question answers regarding the preparation of hydrogen. Today, now I'll start the properties of hydrogen gas. Now, properties of hydrogen gas, there are two types of properties you know. One is physical properties and is chemical properties. Physical properties, that is first point is it is a colorless gas, it is a odorless gas, it is a tasteless gas, it is a soluble, insoluble in water, it is the lightest among all type of gases present in the world in the universe. Hydrogen gas is the lightest element and the lightest gas. So it is the vapor density or the lightest, is very low vapor density, and is a non-poisonous gas. So there are 5 or 6 points in the physical properties: colorless, odorless, tasteless, insoluble in water, non-poisonous, and lightest element. Chemical properties. Chemical properties first is combustibility. Hydrogen gas doesn't support combustion, but it burns itself, the blue flame, and producing a sound that's called pop sound. I repeat, combustibility, hydrogen gas doesn't support combustion, but itself burns with a blue flame and produce pop sound in presence of air or oxygen, or when it comes in contact with air or oxygen. This is the first. Second point. Second reaction. Second reaction will be the reaction with the non-metals. Reaction with non-metal. Reaction with non-metals. First of all, with halogen. You know halogen means they are chlorine, bromine, iodine. Now with halogen, they react directly or direct union or combination takes place, that is to form the hydrides, halogen hydride. That means when chlorine comes in contact with hydrogen fluoride gas, when chlorine combines with hydrogen gas, hydrogen fluoride gas, followed by hydrogen bromide and hydrogen iodide. The condition will be different because chlorine being the most reactive element, when it comes in contact with the hydrogen, no need to any condition, they will produce a icse. But in case of HCl and HBr, they need diffuse sunlight and heat. And for iodine, it combines with the heat and light, it produces HI. Reaction will be H2 plus F2 twice HF, Cl2 plus H2, UV, diffuse sunlight, 2 HCl, Br2 plus H2, UV, 2 HBr plus heat, are I2 plus H2, UV, heat, strong, 2 HI. So, in case of hydrogen fluorine, even in dark, the reaction takes place, but it is diffuse sunlight, the reaction takes place, diffuse sunlight with heat and strong heat for HI. So, gradually the reaction HF, HCl, HBr and HI. The reaction with halogen, we completed. Third reaction, another non-metal, that is nitrogen. Reaction with nitrogen. Now, nitrogen actually is a very inactive element, you know, that's why it doesn't react with any other gas or any other element, but in some drastic conditions they react. Similarly, in case of hydrogen, nitrogen also react. Nitrogen combines with hydrogen form ammonia with some definite conditions. It is found that 3 volumes of hydrogen combine with 1 volume of nitrogen to form 2 volumes of ammonia under a specific condition at the temperature of 450 to 500 degrees Celsius. Alright, in place of finely divided iron catalyst with the molybdenum promoter, and the pressure that will be required is 200 to 900 atmospheric pressure is required for the preparation of ammonia. And this is discovered by the scientist known as Haber. So it is the process is known as Haber's process. Scientists ever discovered this process, so it is known as Haber's process. It is the process by which we can manufacture, we can prepare ammonia industrially. And in the Second World War, it was manufactured by Haber during Second World War, most probably during the Second World War. Now, the reaction will be, let me write the reaction with the proper condition. Reaction with nitrogen, reaction with nitrogen. N2 plus CH2, it forms 2 ammonia. This is known as Haber's process. This is known as Haber's process. Manufacture of, this is for the manufacture of ammonia. Manufacture of ammonia. Alright, and the condition will be, I already told condition, temperature 450 to 500 degrees Celsius, pressure 200 to 900 atmosphere, ATM, and catalyst, finely divided iron, promoter will be the molybdenum. Under this condition, that is temperature, pressure, catalyst, and promoter, 1 volume of nitrogen combines with 3 volumes of hydrogen to form 2 volumes of ammonia, and it is the manufacture of ammonia. It is also known as industrial preparation of ammonia. All right. Next, reaction with carbon monoxide. Reaction with carbon monoxide. Now, carbon monoxide combines with hydrogen to form methanol. Carbon monoxide combines with hydrogen to form methanol. It is also method for the manufacture of methanol. CO plus hydrogen to form methanol means methyl alcohol. Under the condition of L2O3 or Cr2O3 at high temperature. Under some temperature, they combine to form methanol or methyl alcohol. It is also manufacture of methanol. Manufacture means large scale preparation, manufacture of methanol. Next property will be the as a reducing agent. Hydrogen gas as a reducing agent. Hydrogen gas acts as a reducing agent. It reduces some metal oxides to metal, like copper oxide, lead oxide, mercury oxide, iron oxide, etc. They reduces to hydrogen. They reduces to respective metals, like PbO plus hydrogen. We get Pb plus water. Suppose CuO plus hydrogen, we get Cu plus water. Ag plus hydrogen, we get Ag plus water. Okay, Fe2O3 plus hydrogen, we get 2Fe plus 3 water. In those 4 reactions, we find that hydrogen acts as a reducing agent and they reduces the respective metal oxide to respective metals. Like PbO to Pb, CO to Cu, AgO to Ag, and Fe2O3 to Fe. So we can conclude that it is a good reducing agent and reduces the following respective metal oxides to the respective metals. Okay. Next property will be the hydrogen acts as an oxidizing agent. As an oxidizing agent. as an oxidizing agent. Now, hydrogen gas not only acts as an reducing agent, it also acts as an oxidizing agent. Why? It acts as an oxidizing agent because it is found that hydrogen gas reacts with sodium metal to form sodium hydride. Now here, hydrogen oxidizes sodium to sodium hydride. Similarly, twice K plus H2 is equal to twice KH, Ca plus H2 is equal to CaH2. Those are the examples where hydrogen acts as an oxidizing agent. How do we say? Because you see the sodium metal that is oxidized to sodium hydride followed by potassium hydride and calcium hydride. So here we can conclude that hydrogen gas can act as both as an oxidizing and reducing agent. So uh, next is addition property of hydrogen. Addition property of hydrogen. Addition reaction. With ethene. With ethene. Now, ethene combines with hydrogen to form ethane. This is called addition reaction. Why it is called addition reaction? Because hydrogen gas is added to ethene. Hydrogen gas added to ethene. Double bond will be broken to single bond, and then this balance will be satisfied by the hydrogen atom. So here this reaction shows that addition reaction of hydrogen with ethene. Now with ethyne. Here also addition reaction we can say with ethyne plus hydrogen, same condition, platinum, palladium or nickel, 200 to 300 degrees Celsius temperature, we get ethene and the second step will be we'll get the ethane. Okay, conclusion is addition reaction of hydrogen combines with alkene, that is ethene, to form ethane. Ethyne, it combines with ethyne. First reaction will be the triple bond will be broken to single bond, double bond, and finally double bond will be broken to the single bond. So ethyne is reduced to ethene and ethene is reduced to ethane. This is called addition reaction with hydrogen. Addition of hydrogen with ethene and ethyne. Okay, those are the properties of here hydrogen gas. And finally, what will be the test of hydrogen gas, or how will you identify hydrogen gas? Identification or test of hydrogen gas will be what? When a gas jar containing full of hydrogen comes in contact with a burning cylinder, it bursts with a blue flame, the burning splinter bursts with a blue flame and producing pop sound. This is the test or identification of hydrogen gas. Okay, and uses hydrogen gas mostly it is used in case of vegetable oil, because vegetable oil is converted to vegetable ghee. For this manufacturing method hydrogen gas is supplied or is applied for the hydrogenation of, this is called hydrogenation of oil, hydrogenation of oil for the production of vegetable ghee. And it is also used for the as a fuel. As a fuel is very important. Rocket fuel is very important. So we can use hydrogen gas as rocket fuel. Even other fuels also we can use, but it's very expensive or costly. So as a rocket fuel and for the hydrogenation of oil, the main uses of hydrogen gas. Okay, today is no more. Thank you very much. If you like this video, please share and subscribe.